Hello everyone. Today we are going to focus on the FE Civil for structural design load. This is in your FE manual, which is in your page 272, which deals with finding the design load using different load combinations. So in the FE manual, there are two load combinations method. One is using your strength design, which is your L load resistance factor design, and then another one is your ASD, which is your allowable stress design. All these methods give you the maximum load combination, and that maximum load combination we also call as your design load that you're going to use for your for you to design the structure. Either it could be column, tension, or beam, or shear. Okay, so the main objective of this load combination is to design for a worst condition. By worst condition mean maximum load. So you will do all this combination. So it is given in your page 272. There are different types of load. There's that load, earthquake load, life load, floor life load, roof life load, rain load, snow load, and wind load. So if you have all these different loads acting on your structure, then the ASCE 7 has given you a different types of load combination that you can combine, and you can design what is the worst case scenario. So design load is for your worst case scenario. For worst case scenario will mean maximum load. So so in your FE, when you get this kind of question in your FE test, all you have to do is you have to pay attention of what type of loads they are. So in this example, you'll see that there is a dead load. So this is will be D, but then you also have to pay attention to what type of load they are. Are they a point load? Are they a distributed load? Or are they uniformly distributed load, or linearly varying distributed load? So in this case, it is uniformly distributed load, and it is 750 pound per feet at rate of 10 feet. So in this case, you are going to say this as WD. So subscript D mean it is a dead load, and then you have a life load, which is again L, but it is a concentrated load. And generally for concentrated load we wrote P and then L. This means that it's a concentrated life load, and we see that there are different type of concentrated life loads, so we'll denote them as PL1, PL2, and then this will be PL3. And now we are going to use in your question is asking what is the maximum load or design load, or sometimes we call as factor load, because you'll be applying a factor and using LRFD. So now if you go to your page 272, you'll see that there's a load combination for LRFD, and because it involves only life load and dead load, so there are two combinations. One is 1.4D, and then we have the second combination, which is 1.2D plus 1.6L. The question is when to use which one. Generally, you wanted to use, you generally use for both combination, and then find the one that give you or yield you the maximum load. So in this case, you are going to see what how to apply all these combinations. For the first one, because it is a distributed load, and we have WD and WL is 0 in this case. So for the first case, we are going to find a factor load, or WU, which is a maximum load. So in this case, if WL is equal to 0, then we have either 1.4D or 1.2D, but we know that 1.4 is greater than 1.2D, so we are going to go with 1.4D, and in this case it will be 1.4 into 750, and that will give you 1000 . 1050 pound per feet. So that is your factor distributed load. And then for the second case, we need to find what is the factor load for a concentrated load. And in this case, PU, we don't have any concentrated dead load. So because we don't have any concentrated dead load, then we can use the thickened load combination, which is 1.6 L. In this case, it will be 1.6 into 7 plus 3 plus 2, and that will be equal to your 19.2 kips. And now we have to find the total design load or factor load, because it's asking in kips, so which means that we have to convert all our distributed load also into kip. So in this case, it'll be equal to 1050 into 10. Remember that this is, we can change this into 1.05 kips per feet. So this will be 1.05 kips per feet, and we have to convert into kips, and the span is given to us, which is 10 feet. So multiply 10 feet plus 19.2. So in this case, it'll be 29.7 kips. So now our factor load or total factor load will be 29.7 kips. So in this case, what does it mean? It means that if you have, let's say that you have a simply supported load of distributed WU, and then you have PU. So this is what you're going to design in your beam. So you're going to design PU and WU, and then if you combine them together, you'll get a total factor load. And what does this do in your designing? It helps you to find the reaction. When you do the reaction, you'll see that this will be 29.7. We can take the total. This will be R1, R2, and from your structural analysis, summation of all the forces should be equal to 29.7 kips. Okay, so that's what it means by total factor load. Okay, so is R1 equal to R2 equal to half of 29.7? That is only true. Remember, that is only true if the load are equal distance from each other. Okay, if they are, that means your vertical load is symmetric. If it's not symmetric, then you cannot say R1 is equal to R2. So that's why I didn't say here that R1 is equal to R2. I just say that the summation of all the reaction should be equal to your total factor load. This is also in page 272 and 273, which is your floor life load reduction. And here we are only concentrated on floor life load. So this is not the same as roof life load reduction. In your ASCE 7, they have given you a roof life load reduction, but your FE manual only focus on floor life load reduction. So what it means? It means that if your tributary area, that means the area spread around your in your column calculation or the beam calculation, if you have learned in your structural analysis, your tributary area, which means that how much of the area will be contributed or distributed to each member, which is your beam and your column, there you'll see that if your tributary area is so large, then the code permits you to use some life load reduction, and there is a condition on when to use and when not to use. But in this case, in your FE manual, it's just it didn't give you that condition, which means that if you see this kind of questions, then you just have to use the formula and see if you can what if you can use the life load reduction or not, because there is also another condition given in your FE manual. So in this case, you have a 3-story building. So we have a 3-story building, and with columns that are equally spaced in both orthogonal direction, and is subjected to a roof life load. So we have here roof at the top, and then because it is a 3-story building, so that means we have 3 floors. So we have here, this is your first floor, and then this is your second floor. And the tributary area is given to you, which is your 400 feet square, and your roof life reduction is 20 psf, and then you have a floor life load of 40 psf. And now it said that find the life load reduction for the first and second floor column. So this will be your first column, this will be your second column, and this will be your third column. And you'll see that the third column only supporting the roof floor, and there's no roof life reduction for the roof floor. And your second C2, your second column, it will support the second floor and the roof floor. And then your first column, C1, will support the first floor, the second floor, and the roof floor. Okay, so let's see how do we use life load reduction to calculate for each floor in your column. So for first floor column, which is C1, and it has to support 2 floors plus roof. So which means that if it has to support 2 floor and roof, you'll see in your FE manual there is for member supporting. So we are going to look for members supporting 2 or more floor. Okay, so this condition satisfied a member supporting for 2 or more floor. And from there you'll see that the calculation for calculating the life load reduction L is equal to L naught and 0.25 plus 15 square root of K L L A T. And your L naught is equal to 40 psf, and then KLL is given in your FE manual. If you look at page 272, is given that for a for typical column, which is what we are using here, KLL is equal to 4, and for beam it is 2. So right now we are focused on column, so we'll be using KLL equal to 4, and then AT is a total floor tributary area supported by member, and this is excluding roof tributary area. And roof life load has a different calculation, but in your FE manual is only focused on a floor life load reduction. Okay, so in this case, what will be your AT? Because this member C1 is supported 2 floor, which is your first floor and second floor, and each floor the tributary area is 400 square feet. So in this case, your AT will be 2 of 400. That will be 800 feet square. And now if you put all the calculation together, you should get this will be equal to 20.6 psf. And then whether to accept this number or to use a different value for a floor live load reduction, you'll see that there's another condition, that is that this L should be greater than equal to your 0.4 L naught, and 0.4 L naught will be 16 psf. So because this condition satisfied, so we say that your L, your flow live load reduction for calculating for your design for your C1, you can use a flow live load reduction of 20.6 psf. Okay, so that's what that's how you calculated the floor live load reduction. And then the second one is to calculate for C2. So if you wanted to calculate for C2, again the same process. In this case, your AT will be not anymore 800, it'll be only 400. Why? Because C2 only supported a member, only the second floor and a roof, and AT is the total flow tributary area supported by member excluding the roof. So if you exclude the roof, that means C2 will only support the second floor. Okay, so now for C2, it will support one floor plus roof, and which means that this is member supporting one floor. And you'll see that in your FE manual in 272, the L is the same, L naught or 0.25 plus 15 square root of KL AT, and everything remained the same except AT. AT is here 400 feet square because it support only one floor, so your AT also will be it's a member supporting only one floor, so AT will be 400. Again, AT, it exclude the roof floor area. So if you put all the value together, you should get 25 psf, and the condition that this has to be greater than 0.5 L naught, and this is 20 psf, and this meets the requirement or meets the condition, so we can accept that L is equal to 25 psf. Okay, so what exactly means by this condition? So in this condition example, if your L that you calculated for this particular L for C2, let's say that you get 16 psf. If you get L for C2 is equal to 16 psf, and this is not greater than 20 psf, so which means that you have to use L is equal to 20 psf for your design in your design for C2 member. So if you have to consider, if you meet the requirement for that, you need to consider a floor live load reduction, then in that case what will be your live load reduction for this particular example? If you use the formula and you find that your L is 16 psf and it is less than 0.5 L naught, so in that case your floor live load reduction will be 20 psf, so which means that you'll be designing for 20 psf and not for 16 psf. Okay, so that's what that condition means. Okay, so that is your floor live load reduction. And then third one is we're going to use a flat roof snow load. Again, this is these are the topics that is given in your FE manual, and then there's also there are different types of snow loads you'll be calculating, but we are going to focus only on the one that is given in your FE manual. So in this case, it says that an office building located in an area with a ground snow load of 85 psf has an essentially flat roof, assuming a partially exposed heated roof and a terrain category C. Calculate your design flat roof snow load for risk category 2. When I say a different type of snow load, it means that the roof most of the roof is inclined. So the one that is given in your FE manual is on a flat roof snow load. Okay, so which means that your roof is essentially flat, which means that the incline angle will be 0 degree. So in your FE manual, PF, which is your your roof floor snow load or flat roof snow load, is equal to 0.7 CE CT IS PG. Okay, so what are all these values? These values you'll find in your FE manual in your page 273, and you'll see that there are different table to find all these factor. All these are factor. You'll see that CE is your exposure factor, CT is your thermal factor, IS is your importance factor, and PG is your ground snow load. So all these factor, the value are given in a table, and that means in your question all those options are given in your question. So you have to read them carefully what is given in your question, because if otherwise you won't know which value to use. So let's see for your CE, which means that your exposure factor. CE, if you go to your table, you'll see that you need two information. Where it is built, your terrain category, is it in suburban, open terrain, or open water, and how the roof is exposed. Is it fully exposed, partially exposed, or sheltered? In this case, if you look at the question, it says that your building is in terrain category C and it is partially exposed. So your CE, it is in this case your CE will be equal to 1 for category C and partially exposed. And then what is CT? CT is your thermal factor. It is given, you'll see that there are 3 rows. One is all structure except as indicated below. And what are those? Unheated and open air structure. Our structure is our structure unheated and open? No. Is the second case is structure intentionally kept below freezing point. So if you look at our question, it says that it is a heated roof. So if it is a heated roof, that means it has to be all structure except as indicated below. So your CT will be equal to 1.0, which means equal to 1 for heated roof. And then your IS, which is your importance factor, this is belongs on a risk category, how much of the risk the area is designed for. So in this case, it's given that your structure is located on risk category 2, and if you see in risk category 2, your snow important factor IS equal to 1.0 for risk category 2. And then PG is given to you here, which is your ground snow load, and that will be 85 PSF. So if you put all of them together, you'll find that this is 59.5 PSF. So this is your flat roof snow load. So that's how you calculated your flat roof snow load. So you'll see that because the formula is given to you in your FE manual, the question will be very straightforward. All you have to do is you have to read the question and see what are the options, so that you can know which parameters to use in your calculation. And then the last one here for design load will be your wind load. Okay, so for the wind load, your FE this is in your page 274, and you'll see that your wind load is QZ is equal to 0.00256 KZ, KZT, and then KD and V square. And this unit will be pound per feet square or PSF. Okay, so one thing you have to pay attention is the load. Okay, the load unit. In the previous one, you'll see that all these factor are constant and PG is PSF. So if PG is PSF, which is here, then your answer also will be PSF. And here all our load in your previous calculation for flow live fluid reduction, L0 is PSF and AT is feet square. Okay, so your total flow load reduction also will be PSF. Okay, so please pay attention to the unit that is given to you. So that's the only thing about that you have to pay attention in the formula. When you use formula from your FE manual, you should pay attention to the units. So in this case, you'll see that for your wind load, V, which is your basic wind speed, has to be in mph. Okay, that means miles per hour. So let's see that it says for calculating a wind load, it says that a signboard located in terrain category C is subjected to a wind speed of 100 miles per hour. The top of the signboard is 25 feet above the flat ground. Determine the design wind load for a signboard. So again, if you look at the formula, you have KZ, KZT, KD. So which means that these are parameters, and all these parameters will be either given to you or the information will be given to you. So in this case, what is KZ? KZ is your velocity pressure exposure coefficient, and KZ is given in your table, and in your table you have two information that you need. One is the height of the structure above the ground and what type of exposure you are designing for. So in this case, you'll see that we are designing for a terrain category C, and the signboard is 25 above the flat ground. Okay, so height above the ground is 25, so we see a value 25, and open terrain C, which is category C, so your KZ will be equal to 0.94, and then KZT is topographic factor, and it's usually 1 for flat ground, and we are designing for flat ground, so that will be 1.0. And then KD is your wind directionality factor, and it is given in the FE manual. It's 0.85 for most structure. Again, if it's not given to you in the question, you can use a value that is in your FE manual. Otherwise, sometimes in your question they provide you what is KZT and what is KD. And then wind, basic wind speed, again the unit is very important. It's given is 100 miles per hour. So if you use all this value, because this is a formula and all these factors are already calibrated according to the unit, and because we are using miles per hour, so the final value for wind speed will be 20.45 PSF. Okay, so that's how you design for a wind speed using the formula for calculating the wind load in your page 274 in your FE manual. Okay, thank you.